Hello everyone, I am Dr. Ritesh Kumar and going to give the lecture on the topic of communication system, modulation and needs of modulation. The subject name is communication engineering. I am working in the Ajay Kumar Engineering College, Ghaziabad as an assistant professor. So in this lecture, we will basically focus what is the communication system, and for the communication system why we need the modulation and demodulations techniques. So we will discuss in the lecture. So this is the syllabus of this subject, which is divided into 5 units, and each unit had some specific topics. So first unit is totally based on the AM modulation, and second unit is totally based on the angle modulation, and third one is based on the probability random variable units, and the fourth unit is fourth and fifth unit is totally based on the digital communication. So this topic lie throughout this modulation techniques is necessary throughout the communication system. So these are the recommended books by the given by the university. So I will focus on the first. I will prefer the first book, that is Simon Hagen Communication System. Publisher is John Bailey, and the second one is Top Shilling, which is Principle of Communication System. Publisher is Tata McGraw-Hill. So these are the good books to solve the issues occurring in the subject. So you can take it from the library as well. So let's begin the topic. Introduction. What is the communication system? So communication system is nothing but the transforming the information from source to destination, or we can say the transmitter to receiver. So in other terms, we can say exchange of idea, information within the two persons is known as communication system. So if we so there is some certain block diagrams for the basic communication system, as you can see here. This is an information source, right? And this information source, then the transmitter, channel, then the receiver and destination. In the short terms, we can say there is 3 component is required for a communication system. The first one is the transmitter side, that we can say this is a transmitter side, this is a channel, and this one is the receiver side, we can say. So basically we need to have a transmitter, channel and receiver to have the communication between the source to destination. So information source, as you can see, it could be a signal like human voice, picture, data, music, etc. we can take here. And the transmitter is a part of it is a combination of here we can do the modulation. So so you can see here, whatever you are doing at the transmitter side, just do the opposite operation at the receiver side after the passing the information from the channel. Actually you are doing here the modulation, then you need to do the demodulation just at the receiver side, then you can convert the signal in the original form. So this you can see the modulation here. Here you can see these type of signal, we can say this is a low frequency signal, we can say this is a low frequency signal. And you can see here this low frequency signal can be converted into the high frequency signal only by using the modulation techniques. So modulation techniques is a process to convert the low frequency signal to the high frequency signal. This is one of the definition. Also we can say the this low frequency signal also known as the baseband signal. Baseband signal. So the baseband signal is modulation process is the process by which a baseband signal is converted to the passband signal as well. So here you can see why we need the modulation. Then we after this discussion we will discuss the needs of modulation. So here you can see the high frequency signal. This electrical signal is passes through a channel. So this channel this channel you can see here the here some kind of noise. You can see noise is affecting the signal passing through the channel. So this noise is nature of this noise is kind of additive nature. So this is a additive. Here we can say this is a kind of additive white Gaussian noise here. So this noise affect the signal passing through the channel. This channel could be could be in the form of, there are two kinds of channels, such as wired channel. Channel could be in the form of wired or wireless. So different kind of channels which has a wired nature, such as coaxial cable, twisted wire, or transmission line as well. So this kind of channel we can say wired channel. Or wireless is nothing but a free space media, free space channel through which the information exchange takes place. So to have a wireless channel, we have to place the antenna at the transmitter side and receiver side as well. So for the wireless communication, we need to have the antenna, right? So it is required to place the antenna at the receiver side before the channel, at the transmitter side before the channel, and at the receiver side also we need a kind of antenna that receive the signal after the channel. That the channel is nothing but a free space media. So at the receiver side, actually we are doing the modulation at the transmitter side, then we need to do the demodulation at the receiver side. So demodulation process is nothing but it is the process to convert the high frequency modulated carrier signal into the physical signal, that is the original signal. Also we can say it is the process it is the process of separating the signal separating the carrier signal from the modulated signal as well. So this is a kind of this is a process of modulation technique. At last, after demodulation, the information reaches to the destination. So this is the basic block diagram of the communication system that I have discussed here. Now now you can see as I have already discussed what is the information source. Information source is nothing but kind of signal, human voice, picture, data, music, and etc. Transmitter is a kind of a combination of transducer and the modulator. So transducer is nothing but conversion of voice signal. Transducer is a device that converts one kind of energy into the another kind of energy. So here we are using a transducer to convert the voice signal into the electrical signal as well. So after converting the electrical signal, we need to do the modulation at the transmitter side. So here, so we can say transmitter is a combination of transducer plus modulator as well. Channel, as I have discussed, it could be in the form of wired and wireless. So in the case of wire, we require a transmitter antenna and receiver antenna to have the wireless communication. Now the explanation of this is the noise. As I have told you, the noise, the nature of the noise in the channel is additive nature. So that's why we call additive white Gaussian noise. Why we call the white noise? Because it covers the frequency, all the frequency component, all the frequency range, which lies in between minus infinity to plus infinity. As we know, the Gaussian curve is looking like this. So it lies in between minus infinity to plus infinity. So it covers all the frequency ranges. That's why we call additive white Gaussian noise. Now the receiver is a combination of transducer and the demodulator as well. At last, the destination, as I have told you earlier. Now this is the basic terminology that we will use in throughout our communication subject. Actually the terminology starts from baseband signal and transmission. So baseband signal is nothing but the message signal, we can say, or low frequency signal as well. So baseband signal also known as the modulating signal. Modulating signal, message signal, and low frequency signal. So this is the other names of the baseband signal. Here, what broadband signal, the transmission of information message signal in the modulated frequency range, is known as broadband signal. So modulation, as I already discussed in the previous slide, modulation is the process which modifies the carrier signals according to the modulating signals, right? So this is the process of the modulation. So demodulation is the complementary nature of the modulation, the process by which the baseband signal and carrier signal are separated from the modulated signal is called as demodulation, as I told you earlier. So message signal is nothing but a baseband or low frequency signal. Carrier frequency is a high frequency signal that can be used that is used in to modulate the that is used to convert the low frequency signal into the high frequency modulated signal. So modulation and needs of modulation. The process by which the baseband signal modifies the carrier signal is called as modulation, and the resultant signal is called as modulated signal. In other way we can say the process by which the baseband signal and the carrier signal are separated from the modulated signal is called as a demodulation signal. Both are the complementary by nature. So baseband signal is nothing but the message signal, original signal, low frequency signal, etc. So advantage of or need of modulation. So in short term we can say modulation converts low frequency to the high frequency. So why we need to move at the high frequency? Because in electrical circuitry point of view, all the components always be specified in terms of wavelength. So if suppose some component having the length lambda by 2, if I talk about here, the term is reduces the height of the antenna. So you can say every antenna has some certain length, some certain size. All the size of the antenna is specified in terms of wavelength. As we know that suppose if I talk the dipole antenna, so dipole antenna has a length is lambda by 2, and it is the half wavelength antenna as well. So here you can see it defines with the help of wavelength. So as we know that wavelength lambda is equal to c by f, we can say wavelength is inversely proportional to the frequency. So as the frequency increases, wavelength decreases. If wavelength decreases, the size of the antenna will decrease. So suppose if you so you can see here, you can say as the frequency increases, as we move towards a higher frequency, the component and component instruments such as a dipole antenna having will get decreased in size. So this is the one advantage, and the second advantage is the increase in the range of communication. It is justified as if you increase the frequency of the low frequency signal, so it will move far from it will move far the far distance from the previous one. So this is the one advantage of the communication modulation. So avoid the third one is avoids mixing of signal, allows multiplexing of signals, improves the quality of reception. This one by one we will discuss in the further slides. So reducing the height of antenna, as I discussed earlier, I have discussed the case of dipole antenna. Here I am considering the monopole antenna because monopole antenna is just half of the dipole antenna. So monopole antenna is lambda by 4. Generally we can say if the frequency increases, as we know, C by F, frequency increases, wavelength will decrease. So here I have taken the example of lambda by 4, which has the frequency is if I have considered two frequencies. The first one 2 kilohertz, and second one is the 2 megahertz here. So if you calculate the height of the antenna at 2 kilohertz, you can see here it is giving by the 37.5 kilometer, which is practically impossible. While in the case of if you increase the frequency from 2 kilohertz to 2 megahertz, you can see here the length you are getting is 37.5 meter. Kilometer to meter you can convert it. So it can easily constructed, but this the first case, the height of 37.5 kilometer, practically impossible to implement the antenna. So this is clearly justify that if you increase the frequency with the help of modulation, you will get the reduction in the height of the antenna. This is the biggest advantage of doing the modulation. Increase the range of communication. So this is clearly, we already know that if you have the low frequencies, it will travel the uh, small distance, while if you increase the frequency, it will travel the long distance, right? So here already all the things we have discussed in the previous slide. So the third one advantage is the avoid mixing of signals. So as you can see, all the sound signals are within the line within the range of 20 hertz to 20 kilohertz. Uh, the transmission of baseband signal from various sources causes the mixing of signal, and then it is difficult to separate at the receiver, and in order to separate the various signals, it is necessary to translate them all to different signal source. Once the signals have been transmitted, a tuned circuit at the receiver end select the portion of the EM spectrum it is tuned for, right? So you can clearly see in the figure, as there are three signals, you have the signal 1, signal 2, signal 3, all the having the frequency range from 0 to 20 kilohertz, right? So with the help of modulation, you can transmit the signal without interference with each other. That is called as it helps in avoiding mixing of signal. Actually, you can transmit this signal at different carrier frequency. The first signal is transmitted at 100 kilohertz. The second signal is transmitted at the carrier frequency of 200 kilohertz, and the third signal is transmitted at 300 kilohertz carrier frequency. So all these three signals transmitted at different carrier frequency, which helps in avoiding the interference between each other. So that is the another biggest advantage of doing the modulation. Now, the fourth one is the allows multiplexing of the signal. What is the multiplexing? As name suggests, multiplexing. Multi means multiple signals can be transmitted through a single channel. That is called multiplexing. How it can be possible? It can only be possible by using the modulations only. So only at different carrier frequency. So these are the three different signals having some frequency, and we want to transmit all the signals over a single channel. So it can possible with the help of three modulators here, which has a different carrier frequency. That in first modulator f1, second f2, and third one is f3. So at different carrier frequency, the first signal is modulated and it gets it transmit at different frequency. Second signal transmitted at the second carrier frequency. Third one is transmitted through the third carrier frequency, and over the channel it cannot interfere with each other due to having the different carrier frequency. So we can say multiple signals can be transmitted over a single channel with the help of different carrier frequency modulation, right? So we can say modulation helps or allow multiplexing of the signal as well. Improves the quality of reception. So the signal communication using modulation techniques such as frequency modulation, pulse code modulation reduce the effect of noise to great extent. Reduction in the noise improves the quality of reception. So this also helps in improves the quality of the reception. Now the next slide is based on the electromagnetic wave spectrum. So you can see this is a electromagnetic wave spectrum, and you can see here this is the frequency range. As this wave is specified, as we move over the scale, the frequency gets increased, and at this point frequency gets very high here. So this you can see this is the range of microwaves and microwaves. So it has some certain bands such as L, S, C, X, Ku, K, K, etc. So we will see what is the what is the application of different band of this electromagnetic spectrum here. So this is the frequency spectrum designations. So you can see here we have categorized the spectrum in very low frequency range, medium frequency range, high frequency range, very high frequency, ultra high frequency, super high frequency, and extremely high frequency, right? So this is the frequency range we have shown here, right? So this is the frequency range. So these are the application or services we use at low frequency, etc. So you can see for the radar, the extremely high frequency range is required, which lies in 30 gigahertz to 300 gigahertz as well. So for the mobile communication, local wireless network, the super high frequency range is required, that is 3 gigahertz to 30 gigahertz. So these are the different application of different frequency band. So these are the microwave band designation specified by the IEEE. So you can see this is the old name, or these are the new name. So these are the well known microwave bands such as L, S, C, X, KU, K and K, and these are the frequency range. L band lies in between 1 to 2 gigahertz, S 2 to 4 gigahertz, and X 8 to 12 gigahertz, and K 20 to 26.5 gigahertz, and etc. So these are continuous wave modulation techniques. So different kind of modulation techniques we have. The first one, the amplitude modulation, frequency modulation, and phase modulation. So amplitude modulation is modulation in which the amplitude of the carrier signal changes in accordance with the instantaneous value of the message signal or modulating signal. If the frequency changes in accordance with the instantaneous modulating signal, then we can say this is a frequency modulation. If the phase changes in accordance with the instantaneous value, then we call this one is the phase modulation. So these are the modulation techniques we will use we use at the transmitter side before the channel, and after the channel we need to do the demodulation process, right? So so in this lecture I have covered the topic of what is the communication system uh, and needs of modulations, and I hope all the topics that I have discussed here uh, that I have discussed here is clear to all of you. Right? Thank you.